The IPCC has just released its synthesis report on the global climate and is divided into three parts, and this video covers the first part, which is status and trends. The synthesis report is designed for policymakers. It's made up into three parts, as I said. The first part is status and trends. The second part is long-term climate change risks and responses. And the third part is short-term responses. They make over 200 statements which they rate in confidence levels from unequivocal to low. Most of the statements they make are either very high or high confidence levels. Increasing greenhouse gases have caused anthropogenic global warming. This is a statement they make, and they call this unequivocal. The global surface temperature anomaly has reached 1.1 degrees centigrade above the 1850 to 1900 average in the decade from 2011 to 2020. Now, why did they choose 1850 to 1900? 1850 marked the end of the Little Ice Age. We'd come out of it, and temperatures stabilized for about 50 years after that. And so they're using that as the baseline. They point out that global greenhouse gas emissions have increased due to unsustainable use of energy, land use changes, national and international production, and individual lifestyle and consumption. The adverse impact of anthropogenic global warming as it continues to intensify. They've divided their assessment into four different areas: water availability and food production, health and well-being, infrastructure, and biodiversity. So let's take a look at each of those in turn. So water and availability, there's some good news and bad news here. As far as physical water availability is concerned, some areas have suffered major droughts and have a lack of water, like California has had for the last 3 years, but other areas have got more water than they normally get, which is a good effect. Whether you get too much water or not enough is an adverse effect on crop production. Animal and livestock is not so clear. Their productivity seems to be both positively and negatively affected depending where you are and what type of livestock you're talking about. Certainly in the areas of fisheries, we've seen lower fishing yields, and that's a problem because about half the world's population depends on fish as its source of protein. Health and well-being, we've certainly seen the advance of infectious diseases around the world. Heat, malnutrition, and harm from wildfires has been a constant theme for many countries over the last few years. These have affected mental health in one sense or another and caused large portions of some populations to be displaced. Next, cities, settlements, and infrastructure. We're seeing both inland and coastal flooding, damage to infrastructure, and all those cause damage to key economic sectors. Biodiversity and ecosystems. We have seen changes in terrestrial ecosystems, freshwater, and ocean ecosystems. But they've not had a chance to assess the impact or the direction of the impact in each one of those areas as yet. But generally the news there is not good. The land is warming a lot faster than the oceans are. The land surface temperature anomaly has gone up by nearly 1.6 degrees centigrade since the 1850 to 1900 time frame. The ocean has gone up 0.88. Now, because there's more ocean than there is land, that's why the average is about 1.1. Global surface temperature has increased faster since 1970 than any other 50-year period over the last 2,000 years. We can look at individual climate parameters and see the impact that these changes have caused. Increase in agricultural and ecological drought, increase in fire weather, increase in compound flooding, increase in heavy precipitation, glacier retreat, global sea level rise, a change in the acidity of the upper ocean, and an increase in high temperature extremes. And each one of those is more likely than the last. Gases have increased since 1750, and that has been caused by humans. We've added about 2,400 gigatons of carbon dioxide to the atmosphere. 58% of that occurred between 1850 and 1989. 42% occurred between 1990 and 2019. So you can see that the rate is accelerating. Carbon dioxide concentrations, which at the time of the report were 410, is now over 420. is the highest in the last 2 million years at least. Some say 30 million years. Methane concentrations at 1866 part per billion and nitrous oxide concentrations at 332 per billion are the highest in the last 800,000 years, presumably measured from ice cores. Climate extremes become more widespread. This is illustrated here with this plot. For example, the annual hottest day will increase in most mid-latitude regions. You can see here this is the first row of this plot, and the hotter it gets, the more widespread it does. It's interesting to note that the picture on the far right shows that we have annual hottest days in the highest latitudes by far more commonly than anywhere else. Some areas gain more soil moisture, but most productive farm areas will lose. The green areas here are gains of soil moisture. That's in sort of the central part of Africa and some parts of Asia. But most of the US, most of Europe, and north part of South America, where a great deal of food production goes on, are going to lose big time. We'll get more wettest days. There you can see that with the bluish area across the globe. This corresponds pretty much to what we're seeing up above, but the amount of change is actually quite substantial. The dark blue is 40% increase in rainfall. The people that are going to be most affected by temperature rise are those that are being born about now. We have here the increase in emissions over the coming years, very high to very low, and those different scenarios affect global temperatures in different ways. If you're born in 2020, you are going to be deeply affected by the time you reach middle age and old age. Less so for those born in 1980, and those of us like myself who are older will hardly be affected at all. But that doesn't mean we shouldn't be doing something about it. We seem to be heading in the wrong direction. Greenhouse gas emissions have been estimated to be 59 gigatons equivalent of carbon dioxide in 2019. That's 12% higher than in 2010 and 54% higher than in 1990. The largest growth in greenhouse gases is occurring in carbon dioxide from fossil fuels and industrial processes. 78% of greenhouse gas emissions came from the energy industry, transport and buildings. 22% came from agricultural, forestry and land use. The problem is that any improvement we made in any of these areas is more than offset by increase in activity levels in industry, energy supply, transport, agriculture and buildings. There is an element of social injustice about this, a fairly large element I would say, is 35% of the global population emit more than 9 tons of carbon dioxide per person. 41% of the global population emit less than 3, so a third of that. Poorer areas and island nations emit half of that yet again. So 10% of global households contribute between 34 and 45% of the emissions. The bottom 50% contribute only 13 to 15%. So what can we conclude from all of this? Unless we cut emissions sharply, children being born today will suffer higher consequences than the people currently living. Poor and undeveloped countries need to access to zero carbon emission technologies to allow them to catch up with us without harming the environment further. That will need financing on a large scale. It's remarkable how we could find money to support wars and banks rather than fix a major problem that's affecting the whole planet. That's it for today. Thank you for watching. Parts 2 and 3 will come along shortly. And until next time, stay safe and goodbye.